Why do we need quantum computers? Classical computers gave us the internet, smartphones, and even sent humans to the moon. But try asking one to simulate a single molecule like caffeine to understand how it impacts our brains. It's impossible. There's just too much information. Quantum computers may be ideally suited to it. By encoding information into quantum states, quantum computers may make calculations that we only dream of today. So we could one day use a quantum computer to finally understand how caffeine's wake-up magic works. IBM is already making quantum computing more accessible than before with open-source developer tools called Qiskit and the IBM Q Experience, a free way to experiment. It's accessible from virtually anywhere. Millions of experiments have already been run on every continent, even Antarctica. Here's how it works. You enter instructions on a classical computer which travel to a quantum computer hosted on the IBM cloud. The instructions translate into microwave pulses with frequencies and shapes that control qubits and change their quantum states. As the pulses travel over cables to reach the qubits, they go from room temperature to negative 459 degrees Fahrenheit, which makes outer space look warm. This movement to the area of such cold temperature only takes about 0.0001 of a second. After the microwave pulses interact with the qubits, any results are returned back along the cables where they are converted into data that classical computers can interpret. Finally, those results are sent back to you. Each of these IBM Q experiments gets us a little closer to realizing quantum computing's awesome potential to solve a new class of science and business problems. Learn about quantum computing or try it yourself. Share this video if you're excited about a future with quantum computing.